Hello everyone, hope you are doing well. In the previous lecture, we have seen this the single line diagram of Assam. So in this network, what we can see, it consists of 5 energy, that means generator sources and all other the loads. Okay, basically in the network, the number of generators will be lesser than the loads. Okay. So in this network, it is a vast network. Okay. So you can see that this is a very vast network, but there are four. This is NRPP and near to the Kruger AGBP. The generator, one generator is this unit is there. So here one Popili and a Langpi and somewhere Langpi is there. Somewhere okay, link. Simply these are the generating station, but others are basically loads. Okay, so the network is very big network. Okay, so in such case, what we could do, we can take a simple one. Okay, so how we can take a simple network, so that for that presentation, for the presentation purpose, we can take this. So suppose we are taking as a IEEE 4 bus system. So what is the meaning of this IEEE 4 bus system? So IEEE 4 bus system means what? So this system is already operating. This system will be the standard one. Okay. So in the power system network, so this is the network. So this is the bus 1, bus 2, you can consider. This is bus 3, bus 4. So in this network, one generator is there connected to this, another one is connected to this, so another one connected to this, and this is the load. Okay, this is the load. So how these are connected? This bus and this bus is connected through this to this, and this is connected to this, and this is connected to this. Okay, and this line also connected to the this. So this bus number 1 we can put, bus number 2, bus number 3, bus number 4. So as we consider, just see in all the network in Assam. So what, the network is very big, but on the generator there are 4 generating units. Okay. So here also you can see, suppose this is the transmission purpose this network is using. So in this case, suppose in the transmission line, you can consider, suppose this is a 32 kV level transmission. Okay, 32 kV level transmission. So what? But the generator limit, so generator maximum limit in India, the voltage level capacity 25 kV. Okay, there are certain limits not to generate the maximum kVA. Okay, so for that purpose, what we should do? We should step up the voltage level. So for this case, we have to place the transformer. So in all generator case, we have to place one transformer to get the step up voltage. Okay, whatever the requirement, it may be 400, maybe 132, whatever, or 33, whatever the level. And this network is consist what? Obviously parameters are consisting. Parameters, the transformer bole to are resistance, equivalent resistance and impedance we can present as a transformer. So for this also equivalently, mathematically what we can present? Rx, in terms of Rx. So if this way we can present, so and also we are considering this length, line length of this, these are the shorter line length, means shorter means transmission line within 80 kilometers. Okay, transmission line. So short transmission line, medium transmission line, and long transmission line. So what do we know? As the Indian frequency, what 50 Hz, and the length L, so it should be less than 4000. So this is 50 Hz, and this length is in kilometer. So what we could get? So the line length would be 80 kilometer. For medium transmission line, what? The FL less than 10,000 and greater than 4,000. Okay. So the line length almost 80 to 2000 kilometer. And for this long transmission line, what we could say? So for long transmission line, FL greater than 10,000. For that case, the L is greater than 200 kilometer. For this case, we are considering this line length R is shorter line length. Okay, that means operating frequency 50 Hz, and it is operating, means the line length of this is less than 80 kilometer. Okay, or 80 kilometer. Okay. So now this is the configuration. So as we know, the line parameters are there. So line parameter consists for the shortest line, short line is R, X, inductance and resistance. So if inductance and resistance is included, so what we could get? So there would be the equivalent admittance, suppose for 1 to 2, equivalent admittance 1 to 2, for this line 1 to 4, for this line 1 to 3, 1 to 3, for this line 3 to 4, for this line 2 to 4, in this way. Okay. And one more thing we have to focus on is the current injection. Suppose this generator as a voltage source. Okay, we are presenting as a voltage source, here also presenting voltage source. So what we could get? So for a generator, if it is voltage source, so firstly what we have to take? We have to convert this source as a current source. Okay, because this we are interested in the current injection to the network. Okay, so if this is a network, so this is buses, these are the bus. Okay, so now in this this is the load must be, and for this generator, here also you can connect some load, local load, here also you can connect some local load, but we are interested in the current, how much current is injecting into the network. So if generator is there, so we are interested to the first generator, so current injecting to the network I1, for this I2, for this I3 in such way. But for if it is a load bus, only load bus, there is no generator, so what we could do for this? So for this also we will take the same convention of the current injection, but it would be the only I4, but the current injection in is that it is will get the negative current. Okay, for this, because for the load means it is current is going out from the network. Okay, okay, the power is delivering, so in that case it will be but notation, for taking notation it will be in the same way. Okay, but the actual direction would be different, means opposite to that. Now if this is a voltage source, how we could present as a voltage source? Suppose just I am presenting 1 volt. Okay, suppose here it is voltage source, okay, with, so if generator is a voltage source, okay, so what we could get, so this is voltage source, the current conversion, what we could get E and Z. So what we could get, we can convert into the current, okay, and E by Z, okay, this is the conversion, E by Z, okay, or suppose it is internal voltage is there, E, okay, so now it is converting into Z, E by Z, and it is connecting into the bus, okay, so this way we can present, okay, and for the generator source is there, but we are interested on the current injecting into the bus, okay, so this current is, how much current is injecting into this bus, we are considering for this, from this bus to this, okay, that means from this point to this point how much resistance is there, okay, so what, suppose for the generator, suppose generator RG plus XG, okay, and this is impedance of generator, and here we can consider the impedance of what, the transformer, RT, so this is includes, and here we equivalently present the E, okay, now what we could present in equivalent, so RG plus XT plus RG plus RT transformer, okay, in this way we can present the impedance, so this is the equivalent impedance, okay, for one section. So now conversion of current, what we could get, so current is injecting in this way, okay, current would be injecting in this way, and the impedance would be the what, E by equivalent impedance, okay, so what it would be, the equivalent admittance, so this is the conversion of current, okay, so where one bus will be there, so in this way if we get the injection current we will get, okay, if there is a voltage source given, so we have to first convert into the current injection to the network, okay, for each case we will get, so if you get the modified one, so take, so this is one current source, okay, with, suppose we are taking the admittance what, so this is admittance for one bus we are taking as a 1 0, okay, and this is 1 2, and for this also we are taking the current source, this is current source, current injecting, here it is current injecting from 2, and the admittance is Y20, okay, and for this Y30, this is 3, and this is the load. For the load, what the 4 current is injecting 4, and why this branch is not considerable? Because this is very high. For load impedance, this impedance is very high, so that's why this branch is not considerable. Okay. So for the calculation of the network admittance, the load impedance are very high. As we know, the load impedance basically very high, so that's why this is not countable into the network. Okay. So only the transformer, generator, the transformer line, suppose supporting elements, suppose reactor, capacitor, okay, so network element, so these are considerable into the network configuration. Okay, but the load impedance are not considerable into the Ybus matrix. Okay, so now we are interested into Ybus. Okay, so for this network, what we got? So this network 1 by 1 2 line admittance is 1 by 1 2, 1 by 1 4, 2 by 2 4, 1 3 and 3 4. So as we are interested in this, okay, so this is 3 0 and this is. So before going to discuss the Ybus formation, how to get the Ybus formation. So there are several methods of Ybus formation. First one is the Ybus formation method is, first one is the direct inspection method. Direct inspection method. Direct inspection method. Direct inspection method. Second one is singular transformation. Singular transformation method. And third one is the building block. Algorithm. Okay, so first one is very simple one. So direct inspection method, this is just observing the network, so we can form the Ybus. Okay, so how we will get? So it is limited, only very less number of buses is available. Just seeing the network, you can simply form the Ybus. Okay, but singular transformation method, whatever the number of buses available, so you can make an algorithm and then you will form the bus for the network. If we know the parameters, line parameters values. Okay, so in the same way building block algorithm also is there, so you can make. So now first we are interested into making the Ybus matrix. So in case of Ybus matrix, we will interested in the current injection to the network for each bus, at each bus, and the bus voltage. So bus voltage for bus 1, bus 2, bus 3. Accordingly, we are taking the bus voltages V2, V3, V4 as the bus voltages. Okay. So now what we could do? So bus injection current, if we take the injection current VI1. Okay. Now what current from this to the current is in this way, from this branch it may be in this way, but current injecting in this way, but for this current is so Y1, Y10. Okay, and 1 to 2 what class 1 to 2, y1 to, just I am applying KCL at bus 1. Okay, for this, suppose we are taking the current direction from this one, 1 to 2, and this is 1 to 4, this is current 1 to 3, current 1 to 3, 4, 3 to 4, 3 to 4, current 2 to 4. Okay, so in such case, the V1, V2, 1 to 2, and V1, V3, 1, 3, plus V1, V4, 1, 4. So this is the equation 1. For equation 2, or at plus 2, what we could get? Bus 2, y2 is y2, and v2, v4 as 2, 4 minus v1 minus v2 y1, 2. This is question number 2, current injecting. And for current injection 3, 3 to 4, so v3 y0. So what we get? v3 4 v4 minus v1 2 3 1 3, and for I4 what we could get? Minus v1 v4 y1 4 plus this is also minus v1 v3 minus v4 v4 minus v2 minus 4 is y4. So these are the equation, 4 number of equation of current injection. So as I told earlier, so for I4, this is also we are considering as a current injecting, but it is not a current injecting node because there is a no generating source. But for your convention, so I am taking as a current injection, but it's in the mathematical way, its magnitude and direction would be different. Okay, not like if it is a generator is connected. Okay, so what we could get? So if you form, this is I1, I2, I3, I4 as a matrix for the current injection. So this is the matrix you can get in terms of voltage. Voltage V2, V3, V4. So here we could get some elements. So this is Y11, Y12, Y13, Y14. So Y21, Y22, Y23, Y24. In like this, you will get one matrix. So this Y are putting in the capital way. Okay, in the capital. So these are the elements of a matrix. So this matrix is known as Ybus matrix. And so the current is the injection current matrix at buses, and this is the voltages, bus voltages. These are the V1, V2, V3, V4 and the bus voltages, and this matrix, whatever the matrix will form, so that matrix will be known as a Ybus matrix. Okay. Now what will be interested on these elements? What are the elements? So from the matrix, what we could get? So the Y11, the matrix, first element what would be? The first element Y10 plus Y12 plus Y13 plus Y14, because this is the self admittance due to generator and transformer, but these are the component contribution for the other, if this bus is connected to other buses, so for their contribution. Okay, for B12 Y12, what you can get? Minus Y12, Y13 minus Y13, Y14 minus Y14. Clear? So these are the components. Okay, the small Y1 is, this is the equivalent admittance of the line, but a capital Y12 is the matrix element. Okay, just presentation. Okay, so in the same way you can get all the elements, okay, for that particular bus. Okay, so you can simply observe that this one is the direct inspection method. Just by seeing this network, suppose in very less number of buses are there in the network, so you can simply see this network and you can form the Ybus. Okay, but if there are number of buses available for this case, so what are the buses? Now what number of buses? No, by seeing this network it is not countable. Okay, how many number of buses? It may be exceeding the 150 or 160. So for this network, by simply seeing the network, you can't calculate the Ybus. Okay, so for that you go for the algorithm, you go for the programming. So then only you can form the Ybus. Okay, so this is the way of presentation of Ybus. So in the later way, in the next lecture, we'll discuss one problem, the formation of Ybus with this direct inspection method. Okay, and other thing is available. Suppose this line are not shorter line. Suppose this is the T means medium line, here long transmission line. What would present? And how we could get the other transmission line elements? Okay, and the modification and the deletion. If suppose one network element is delayed, means what would be the modified network? Modified Ybus. If suppose there is an inclusion of bus, what would be the modified network? So in those things we will see in the next lecture. Okay, and all the algorithm whatever I have just mentioned, the singular transformation method and building block algorithm method. So this we will discuss in the later course. Okay. Thank you all. God bless.